Alrighty, let's get started on this quiz review for Unit 8, the quadratics unit. Question 1 says, question 1 and 2, describe the transformations that would produce the graph of the function g from the graph of the given parent function. Alright, so if we start out with this, they want to know each thing that's different, what did it do to the graph? So first, what did this 1/2 do? Well, when it's 1/2 in front, that number is smaller than 1, so you say wider by 1/2. Perfect. Then the -2 in parentheses. The -2 in parentheses is the opposite of what we would think. It goes to the right 2. And the -3 on the outside means we go down 3. Good job. All right. Very similar. Let's look at number 2. So instead of having x squared, now we have this +1 inside the parentheses. Inside the parentheses tells us to go left or right, but it's the opposite of what we think. So since it's plus, that means we go to the left 1. And then this +3 on the outside means we go up 3. Because outside means we go up or down. All right. Now, question 3 or 4, we are going to rewrite these in vertex form, and we're going to state the vertex and the axis of symmetry. So let's do this now. We start by bringing the constant over. You could change f of x to y if that makes you more comfortable. I'll just keep it. So we have f of x minus 12 plus a box equals x squared minus 8x plus a square. I say square because we are doing the method of completing the square. All right, now we have to go like this, put our x, and the number that goes inside parentheses is we take that b term, the -8, and we divide it by 2. -8 divided by 2 is -4. Now if we square -4, we get 16. Perfect. So then on this side, we will have f of x, -12 plus 16 is +4. And now we would -4 on both sides, and our final answer would be f of x equals x minus 4 squared minus 4. Perfect. All right, now our vertex. You switch the number in parentheses, so instead of a -4, it's going to become a +4, and you keep the outside number the same. And now for our axis of symmetry. It's x equals whatever the x number is in the vertex, which is 4. Perfect. All right, let's look at this next one. You might want to pause the video and try it, see if you could do it on your own. All right, I'm going to bring over the 14. I get f of x minus 14 plus a square equals x squared minus 6x plus a square. All right, now make my parentheses x squared. Inside the parentheses, -6 divided by 2 is -3. And then -3 squared is 9. Good. So then we'll have f of x, -14 plus 9 gives me a -5. And I want to bring that -5 over, so I'm going to add it. And I will end up with my final vertex form is f of x equals, parentheses, x minus 3 squared plus 5. And now let's write down the vertex and the axis of symmetry. The vertex would be we have to do the opposite, so 3, comma, the outside number stays the same, 5. And axis of symmetry, you always have to write x equals, and it's whatever the x value is in the vertex, which is 3. Perfect. All right, let's look at number 5. They want us to state the domain and range for the given function below. All right, if you remember, domain means how much to the left and how much to the right does this graph go. So if I follow this all the way to the left, this is a point. And what x value is that point? -3. It's a closed circle, so I put square bracket, -3. And now let's go all the way to the right. This is the rightmost my graph goes. And I look at what x value that is. That is 3 with a closed circle, so I put a square bracket. And now let's look at our range. I'm going to look how low does the graph go. How low it went is down 1, 2, 3, 4, 5. So square bracket, -5. And how high does it go? Right here, which is 4 with a square bracket. If they were arrows, then we would have infinities, but no arrows here. Alrighty, let's look at number 6. Again, state the domain and range, so try this one, see if you can do it. Domain, how much to the left and how much to the right are the x values? So let's look all the way to the left. Ooh, it's an arrow. And if we're going to the left, we're going towards -infinity. And over here, the right is also an arrow. Good. And now let's look into our range. How low does the graph go? The lowest is right here, and those are our point, so square bracket, -3. And how high does it go? This is my highest point, and it's an arrow, so it's going towards positive infinity. And infinity always gets parentheses. Alrighty, let's look at number 7. What are the x-intercepts of this graph? Well, I'm just going to do this using my graph. Let's type it in. X squared minus 9x plus 20. Let's go look at a picture of the graph. I see it's crossing at 4 and 5. +4 and +5. Perfect. All right. Question 8 through 10. Solve the given equation using the factoring method. Okay. Let's look at number 8. We're going to first see if there's a GCF we could take out. Ooh, well, the smallest number is 3, and 36 does divide by 3, so we can do that. And they both have an x, so we're going to put 3x. All right. So we will be left with 3x parentheses. 3 divided by 3 is 1. X squared divided by x is just 1x. -36 divided by 3 is -12, and the x's would cancel out. And bring down the equals 0. Now let's set each one equal to 0. 3x equals 0. Well, you would divide by 3, and you would end up getting x equals 0. And then x minus 12 equals 0. We will add 12 to both sides, and we get x equals 12. Perfect. All right, let's look at number 8. See if there is a GCF. Well, the smallest number is 11. Does 132 divide by 11? It sure does. So our GCF is going to be 11, and because they both have an x, it's going to be 11x. Okay, 11x parentheses. I'll just be left with an x. -132 divided by 11 is -12, and the x's cancel out. So we're going to have 11x equals 0. We have to divide by 11, and we get x equals 0. And then we have x minus 12 equals 0. We would add 12 to both sides, and we get x equals +12. Perfect. All right, number 10. Let's see if there is a GCF. Well, the smallest number is 4. Does 64 divide by 4? It does. So we're going to take out a 4. But here we cannot take out an x because both things don't have an x. So our GCF is 4. 4 divided by 4, we could forget about that. Just bring down the x squared. -64 divided by 4 is -16. Okay. Now, we could also separate this x squared into 2 different parentheses. It would leave us with x and x. And the square root of -16 is -4 and +4. Now we are going to set all of these things equal to 0. 4 equals 0? No way. Okay. X minus 4 equals 0. Well, instead of -4, we're going to add 4 to both sides. and we get x equals 4. And then the x minus 4 equals 0. Oh, the x plus 4 equals 0. I'm doing the second one. We subtract 4 from both sides, and we get x equals negative 4. Perfect. This is the factoring method, or the zero product property. All right. Now let's look at number 11. The quadratic functions Rx and Qx are given below. The function with the smallest minimum is. All right, let's see what the smallest minimum is. In this one, our smallest point is this negative 16. Okay. And now let's go look in the graph of the Qx one. So I'm going to graph it on my calculator. X squared plus 2x minus 8. And let's go see what our minimum point is. I'll look at the table. That's easier for me. I'm going to look for the number that's like not repeating. It's this negative 1, negative 9. So which one's smaller? Definitely the negative 16. So that's the R one. So Rx. And the smallest value is the negative 16. Good. All right, let's look at this next one. Which quadratic function has the smallest minimum value? Okay, almost the same. Here, I'm trying to look for the number that doesn't repeat, but everything does repeat, which means my vertex is somewhere in the middle here. Maybe it's like 2.5, comma, and then it's something smaller than 0. I don't know what, but it's something smaller than 0. Okay, let's look at this next one. What is this minimum value? 6 parentheses x minus 2 squared minus 2. And let's look for it. Which number here is our vertex, the one that doesn't repeat? It's 2, negative 2. I could have also got that by pulling it out of this equation, flip that one, and keep this one the same. All right, so let's see which one is smaller here. Okay, I'm still not really sure. Let me look at the next one. 6x squared plus 5x minus 2. Let's look at our table. What's the smallest number here? Our vertex is... our vertex is kind of in the middle, so I actually have to do my own work to find it. All right, let's use the negative b over 2a formula. Negative b is 5 over 2, a is 6. And this would give us negative 5 over 12. And we need to find the y value for that, so we could plug in this number. All right, so let's see this. 6 times negative 5 over 12 squared plus 5, negative 5. Oh, I just canceled out. Let's make it easier. Let's just store in the fraction negative 5 over 12. And let's store it for x. And let's type in the problem. Oh, it didn't want to work. Okay, whatever. We'll just do it the old-fashioned way. Negative 5 over 12 squared plus 5, negative 5 over 12 minus 2. All right. And I get negative 73 over 24. So these would be my my vertex. I just want to know what number that is. Negative 73 divided by 24 is negative 3 point something. Okay. All right, and this last one, the minimum value is 0, 0. So that's definitely not going to be my answer because I already have ones that are negative. All right, minimum value here is something smaller than 0 for this one. This one is negative 2, and this one is negative 3. So the smallest one would be the negative 3 one, so choice B. Good. All right, let's look at number 13. A polynomial factor contains the factors x minus 2, and x plus 5. All right. These are kind of not what we learned yet, but we will just go over them. It's pretty easy. If you have a factor x, that means you would write x equals 0. We need some graph that goes through 0. This one goes through 0, this doesn't go through 0, and this one goes through 0. That's good. Now, if you had x minus 2 equals 0, after you would solve it, it would give you x equals 2. So that would be this one, not the next one, so our answer has to be choice 1, which the only one that has 1 in it is choice C. That's called a cubic function. It's not a quadratic that we've been learning, but it's the same steps that we've been doing. All right, for this next one, here we go through x equals negative 3. Here we go through x equals 2, and here we're going through x equals 4. When we want to put this back into a polynomial, inside the parentheses, we choose the opposite. So here it would be x plus 3. So I need one that has a plus 3. And there's only 3 factors, so I just need one with 3 parentheses. So my answer has to be choice D. All right, number 15, what are these zeros? Let's just type it in the calculator. X squared minus 2x minus 15. Let's go to the table and let's look. Well, we could look at the graph, I mean. That would be 1, 2, 3, negative 3, and a positive 5. Choice A. All right, let's look at the next one. Let's type this in the calculator. 2x minus 4 and 3x plus 4. What are our zeros? Let's look at the picture big. Our 0 has a positive 2 in it, so it can't be B, and it can't be D. And then it has some decimal, which is choice A. Perfect. Let's look at number 17. Richard is asked to transform the graph below. The graph of b of x is transformed using this equation. Describe how this changed. Okay, well, when we have a number inside parentheses, that makes it go to the, we have to think of the opposite, the right 2. And when we have a negative 3 outside, that makes it go down 3. So the transformations are going to the right 2 and down 3. All right, let's look at this next one. What would this stuff change? If you have a minus a on the inside, that would make it go to the right a. And if you have a minus a on the outside, that would make it go down a. Yes, we are doing quadratics in this unit where there's an x squared, but the same transformation rules also hold true when you have an absolute value function with those lines. All right, now they want us to graph this. That should be easy for us to do. We're going to type it in the calculator. X squared minus 4x minus 1, and let's look at the table. All right, the table. Let me see what smallest number I could do. I could do negative 1, 4, 0, negative 1, 1, negative 4, 2, negative 5, 3, negative 4, 4, negative 1, and 5, 4. Let's go ahead and graph this. 1, 2, 3, 4. Then 0, negative 1. 1, negative 4, 1, 2, 3, 4. 2, negative 5. 3, negative 4. 4, negative 1. Oh, it should have been a negative 1. My bad, right here should have been a negative 1. And then 5, 4, 1, 2, 3, 4. Perfect. Now let's connect the points. And let's put some arrows. You have to put arrows because they didn't tell us where to start or stop. And the question says, state the axis of symmetry. Guys, do not say that the axis of symmetry is 2 and then down 1, 2, 3, 4, 5. Negative 5. This is our vertex. This is the middle point. That's our vertex. But axis of symmetry is a line. The line that goes through the middle of the graph, which here it would be x equals 2. All right. Let's look at the next question. We are going to graph this one. Everybody should be good at graphing now. You want to pause the video and try it yourself. We are going to type it into the calculator. Let's just go to the graph, the table, and let's see the smallest number that we can do. We could graph -7, -7, -6, 0. -5, 5, -4, 8, -3, 9, and then everything else starts to repeat. -2, 8, -1, 5, 0, 0, and 1, -7. And let's graph it. -7, down 7, 1, 2, 3, 4, 5, 6, 7, and then go down 7. 1, 2, 3, 4, 5, 6, 7. All right, -6, 0, -5, 5, 1, 2, 3, 4, 5, -4, 8, 1, 5, 6, 7, 8, then the 9, then the 8, then the 5, then this, and then that. All right, now we are going to connect our points, and we are going to put arrows looking downwards. And the question says, what are the coordinates of the vertex? Oh, what is the vertex? What is this middle point? It is -3, and you went up 9. You could also see this in your graph as long as it's a whole number by whatever number does not repeat. All right, 21, they want me to solve for this algebraically. Okay, so let me bring my 36 over because I need it to be equal to 0. So I subtract 36, and I get x squared minus 9x minus 36 equals 0. Perfect. There is no GCF to take out here. So I am just going to be finding what adds to -9 and what multiplies to -36. That would be 3 and... Oh, we could do 3 and 12. A -12 and a +3. And then when I set each of these equal to 0, I would be left with x equals +12 and x equals -3. Let's look at the next one. They want me to solve algebraically again. There is no GCF here, so I'm going to be finding what adds to -9, -8, and what multiplies to -9. That is going to be x minus 9 and x plus 1 equals 0. And the opposite would be to have x equals 9 and x equals -1. Explain my first step. My first step was to look for the GCF and then factor the trinomial. Perfect. All right, let's look at 23. What are the roots of this equation? Guys, it's multiple choice, so we don't have to actually show our work. Let's just type it in the calculator. 4x squared minus 100. Let's look at our graph. It goes through 5 and -5. And let's just go over how we got that answer, because that's also important. You would look and see if there's something you could take out. You could take out a 4. So you would take out 4, and you'd be left with x squared minus 25. That becomes x minus 5 and x plus 5 equals 0. 4 does not equal 0, so that goes away, and then you switch each of the factors, and you get 5 and -5. And that's the same question as 24. The only difference is you need to bring the 100 over by subtracting 100. So then you have 4x squared minus 100 equals 0. That's the same work as up here. Just it could be x as multiple choice where you can look at the graph, but if it's long response, you have to do it on your own. All right, number 25 says to find these solutions by taking the square root. All right, in order to do that, we first have to get this squared by itself, which is connected to this x minus 2. But I have the 6 on the outside I don't want. Since it's being multiplied, I divide it. So I would get x minus 1 squared equals 324 divided by 6 is 54. Perfect. Now I'm going to take the square root of both sides. Anytime you take the square root of a number, it is going to be plus or minus. And now let's simplify that radical into square root of 9 with the square root of 5. And the square root of 9 becomes 3. Leave square root of 5 alone. Then I don't want that positive one, so I'm going to add 1. And I would get x equals 1 plus or minus 3 square root of 5. Perfect. Now let's look at the next one. We need to get this thing by itself. So first we need to add the 64 to both sides. That would give me 2 parentheses x plus 3 squared equals 64. Now, I don't like that 2 there because I'm trying to get the parentheses by itself. So I need to divide. So I would have x plus 3 squared equals 64 divided by 2 is 32. Now I'm going to take the square root of each side, and I get x plus 3 equals a positive or a negative. The square root of 32 can simplify into 16 and 2. The square root of 16 is 4. Leave square root of 2 alone. And now we don't want that plus 3 there, so we're going to subtract 3 to both sides. And our final answer will be x equals negative 3 plus or minus 4 square root of 2. All right. And that wraps up our review. So make sure you guys know how to graph quadratics. Make sure you know how to write things in vertex form. Make sure you know how to solve taking the square root or solve by factoring. And make sure you know the difference between axis of symmetry and the vertex. All done.